Hello and welcome to the Hydrocarbon Engineering Podcast. I'm your host, Callum O'Reilly, and today I'm joined by Andrea Bombardi, Executive Vice President at RINA, who has a wealth of experience working on some of the most significant carbon capture, utilisation and storage projects globally. Andrea provides us with technical and operational insight into some of the key challenges and opportunities of CCUS implementation as we try to shed some light on the complicated path to commercial viability. So let's talk to Andrea.
The Hydrocarbon Engineering Podcast is brought to you by Owens Corning Foam Glass Insulation. From managing vapor drive and mitigating corrosion risk, to maintaining thermal performance and supporting safety on the job site, the insulating system plays a critical role in high-performing hydrocarbon processing facilities. Learn more about how foam glass insulation contributes to the design of high-performing insulating systems at cryogenic facilities at www.owenscorning.com/foamglasslng study. That's www.owenscorning.com/FOAMGLAS LNG study.
Hi Andrea and welcome to the Hydrocarbon Engineering Podcast. Thanks so much for joining us. To start us off today, please can you introduce yourself to our listeners and tell us a little about RINA and your current role at the company?
Hi everybody, thank you Callum for this opportunity. RINA is an international company. Our turnover is close to 1 billion. We are present in 70 countries with more than 6,000 employees. We provide consult engineering, testing, inspection, and certification service. And my role in the company is just to be the Executive Vice President for Global Market Development. I follow up our key accounts or main clients and our strategic stream. One of the strategic stream is energy transition, that is the topic of today.
Great, thank you very much for that, Andrea. So for those that are less familiar, can you give us a quick overview of RINA's role in the energy transition and the kinds of services and projects that you're involved in?
Yes, Carlo, RINA provides services, as I said, all along the value chain, include the use of new energy source or vectors. Since we work in the hard to abate, in the transport and mobility, in the shipping, so all the sector that needs to be decarbonized. And we are agnostic in terms of technologies because we provide service. So we are not exposed to one of a sector, but we follow all the sectors, starting from renewables to hydrogen and derivatives, to bio and synthetic fuels, and carbon capture as well. And we are working globally on these subjects and with an independent, let me say, role, just advising our client on the best technical, economical, and feasible solution for their needs. We start from production, transportation, distribution, storage, as well as the final use that is so important when we change traditional fossil fuel with something different.
So, Andrea, carbon capture, utilisation and storage has been gaining real traction recently, and it's a topic we regularly cover in hydrocarbon engineering, but it's often seen as niche or transitional. So can you tell us a little bit about where you see CCUS fitting into the long-term energy landscape?
Yes, thank you, Callum, for this question. CCUS is not a side note for energy transition. Some people think about carbon capture utilization storage as a bridge technology, so for a transition period, as someone else as a permanent solution in the low carbon toolkits. We think that both perspectives are true, and the path to net zero will be gradual. especially in today's geopolitical climates. And if we see the international agency, let me say, forecast to 2050, a considerable part of energy production will derive from fossil fuel. In the condition will be 14%, but in the most conservative scenario will be 58%. It means that at the end of the day, we have to start to manage CO2 emission because they will be critical in the coming years and cannot be overlooked. CCUS is for sure something that will apply to specific sector. The most important one is the production of cement, because cement is a matter of chemistry. CO2 is produced for twofold from the chemical reaction. So we cannot avoid CO2 when producing cement. But the same will apply to also to waste to energy, to steel, livestock farming. Okay, there are CO2 intense emissions processes. So CO2 is one of the viable options to address them, not only in the short term, but also in the medium long term.
Thanks, Andrea. And now I want to move on to some of the practical challenges of CCUS implementation. So are you able to talk us through some of these?
Yes, we have to scale, CCUS application. And this is not only a technical challenge. The challenge is on the full ecosystem. If we are speaking about the technical side, we must capture CO2 efficiently, cutting costs, scaling up facility, transport it safely, and store it permanently. Long-term storage integrity is something that we have to address and is not negotiable. Infrastructure is another important topic. We have to build pipeline, ports, and the liquefied CO2 terminals. And it takes time, money, and careful coordination. And when you have emitters far from storage site, it has been even more critical. For the offshore reservoir, we also need specialized vessel and loading facilities, as it is applicable today for some of the projects that we have in Europe, the one that we have in Norway that started a few days ago. Another important topic is regulation that is still evolving. Cross-border CO2 transport, long-term storage, liability, and harmonized safety standards remain unresolved in some regions. We need to have clear rules, otherwise investment stall. And last but not least, the public acceptance also needs transparency about safety and environmental impacts.
So I noticed that RINA is involved in 5 of the 15 full-scale CO2 pipeline transport trials that are currently taking place globally. So can you talk about what these trials are teaching us?
Yes, exactly. RINA is among the leading players in CO2 transport research. And we carried out 5 of 15 full-scale CO2 testing worldwide. These kind of tests are needed to provide a great contribution to setting design rules for this emerging sector. In Sardinia, in Italy, where we have our, space to do this kind of test, we build 300 meters pipeline section, and we fill them with dense CO2, including some impurities, and we initiated the controlled fracture with explosive charge. So this is a full-scale destructive testing in order to understand how cracks propagate and can be stopped. Our work is related to to understand better questions for operators, for manufacturers and regulators about the material properties that can guarantee the fracture arrest and how we can design pipeline in a safer way, also considering the expansion of CO2 and during the compression. The results of these studies are the foundation for the CO2 large infrastructure network in order to meet the decarbonisation targets.
So, Andrea, your expertise spans different continents. So I was wondering, what are some of the biggest differences that you're seeing in how CCUS is being approached in Europe and the US and, let's say, the Middle East? And what about in different sectors? So you mentioned cement being really important earlier, but how does that compare to the downstream oil and gas sector?
The reply to your question, Callum, is the fact that we have to consider CO2 as a global tradable commodity if you want to achieve the results. Because today we have different approach continent by continent, also country by country, due to different regulation. In Europe, you have some deployment policy driven, let me say, because we decide to apply for a strong decarbonization path. Okay, and for CO2, we have Norway, Northern Light, we have the UK project, Teesside and Amber, and we have also the Italian Ravenna project, and in Greece, they are developing the Apollo project. But this is not enough. You can see the US, they have a very strong background for oil and gas sectors. They have an extensive pipeline networks. So the deep experience that they have in enhanced oil recovery, that means to pump CO2 in the, let me say, oil field, is a good starting point, but you need different scales and different infrastructure in order just to boost carbon capture, utilization, and storage. We have movement also in China, in the Middle East, and in the Middle East, the carbon capture is also a way to decarbonize the oil and gas sector, diversifying for a low carbon future. And this goes to the sectors, as you asked. For cement, we cannot avoid CO2 capture. This is essential, but also in the downstream sectors, refinery petrochemical processes, CO2 is very concentrated as a flue gas, so capture can be easier and cheaper compared to other sectors. But you need to retrofit all facility, and this could be complex, and without incentives, it's very tough for operators to justify this upfront cost. So at the end of the day, we need a complete and overall view, and as a global challenge, how to face carbon capture.
So you mentioned costs there, Andrea, and I wanted to get your opinion on what's going on with the economics of CCUS today, particularly when it comes to retrofitting existing oil and gas infrastructure.
Yes, retrofitting is smart because it could help just to have a project that is most cost effective. And it's how to use a pipeline that we are transporting, let me say, gas from offshore wells to the onshore, and just to use them for a reverse route and just to put the CO2 underground. This is really something that we have to apply, but every site is different. So you have different technical constraints, you have different operational history, you have different local conditions. So you have to run a proper technical and economical feasibility case by case. Costs are very huge depending on different parameters, okay? The type of emission source, the scale, the location, but the capture is usually the most expensive step in the CCUS value chain. So you need to work on this kind of technology in order just to reduce cost. But as I said, retrofitting is a smart solution in order to speed up CO2 projects.
So when it comes to policies or regulations, what do you think is required in order to unlock investment in CCUS?
I come back to the concept that I highlighted before. We have to consider CO2 as a global tradable commodity. Otherwise, we have barriers, okay? For example, we have different carbon prices mechanisms, and we have to have one consistent. Okay, we have different operational subsidies and investment incentives. We have different permitting processes. We don't have clear rules on long-term storage liability. So we have to harmonize the standards for sure in order to enable the cross-border transport. Because otherwise, we cannot consider that a very industrial countries can decarbonize if they don't have any place to put CO2 underground. Maybe need, to transport to another country the CO2, and this mechanism has to be clear and has to be really straightforward in order just to accelerate the carbon capture development. The framework must cover all the chain, the full value chain. So from the standard related to carbon capture, to the pipeline safety, as said, to the storage and monitoring. These are mainly some of the action that we have to do in order just to boost this kind of way to decarbonize.
So let's zero in on the downstream sector. What are the unique challenges or opportunities when applying CCUS to refineries and petrochemical plants? And are there particular processes that are more suited to carbon capture?
CCUS, the carbon capture in refineries and petrochemical plants, depends on the nature of the flue gas, so the exhausted gas, that is not always the same. For example, the hydrogen production units, when you use steam reforming, are a sort of low-hanging fruit because the related flue gas is highly concentrated in terms of CO2, and so it's cheap to capture it. We have similar story for aromatics unit or coking processes. When we go to heaters, boilers, we have tough case because CO2 is technically capturable, but the dilution in the flue gas may capture more expensive and energy intensive. But technology is something that we have to work on. Okay, today we have different technology for carbon capture from the advanced amine, from the solid sorbent, the membranes. We have a pro-combustion, post-combustion, different technologies. But the technology sometimes is not, let me say, bring to the leading edge of it if you don't have a booming of a market. So now is the moment to understand how you can increase the performance of the technologies, in terms of capturing, but also in terms of reduction of costs, and at the same time to understand if there are any other technology that are of a technology readiness level that today is low, but can be boosted in order to just to have alternative end options in order to capture CO2.
And how integrated is CCUS becoming with other decarbonisation pathways in the downstream sector, such as hydrogen?
Hydrogen and carbon capture are strictly related because we are speaking about synthetic fuels. That is one of the solution for the decarbonization. The synthetic fuels combine CO2 with low carbon hydrogen, And this is the way to decarbonize, for example, the hard-to-abate sectors, or the heavy-duty transport, the maritime shipping, the aviation. You have the infrastructure in place because what we call eLNG is the same of LNG, having a different, let me say, origin. One is fossil, one is not fossil. And we can use the same infrastructure to transport, the same carriers, the same pipelines, and the same terminals. So all the infrastructure is in place for synthetic fuels. But today, to capture CO2 is costly, to produce hydrogen is costly, and just to produce synthetic fuels is costly. So today it's more or less 10 times the cost of a fossil fuel. But again, okay, we have to work on that, and we have to get the momentum, because we have some regulation like the one on renewable fuel, European Union aviation, that are setting targets for sustainable aviation fuel. That includes synthetic fuels. So you have driven from regulation in some place of the world. You are not in some other place of the world. But there is really a very good combination between CO2 and hydrogen in order to develop synthetic fuels.
So a final question from me today, Andrea, and I wanted to just look ahead slightly into the next 5 to 10 years and ask your opinion on what you think the role of downstream CCUS will be.
The role of CCUS will be critical. Today, the CO2 emissions are 37.7 gigatons per year, and the projection of 2050 will be around 12 gigatons of CO2 in the intermediate scenario according to the International Agency. So the announced pledge scenario that is not, it's optimistic but maybe achievable. Okay, it is not an ideal scenario. This brings us to the question, okay, we will need large-scale CO2 management in the next 5-10 years, but the question is how fast we can deploy them. Today, we must admit that the story of CCUS is underperformance compared to its potential. We need to scale up this technology because it's one of the key to decarbonize. We cannot decarbonize without considering the role of carbon capture. And for sure, in the future, we have also to understand what we can do with utilization. So, from one side, to remove and put in permanent storage from our side, how to use CO2 for building materials in order to make synthetic fuels, in order just to reuse CO2. We need a sharp acceleration in scale, investment, and integration with other clean technologies. And we will have a final answer in the next decade in order to understand which will be the role we think will be a predominant role in the energy transition scenario.
Great, Andrea, very exciting times. We really appreciate you dropping by and spending some time with us talking about the intricacies and opportunities of CCUS. So thank you very much.
Thank you, Callum, and thank you all the people that are going to listen to this podcast. And energy transition is really the challenge. It's the most important challenge that the human world have faced ever. So it's very important just to give this kind of content in order just to inform all the people of what is happening for energy transition. So thank you for this opportunity.
Thank you, Andrea. Thank you very much. That's all for today's episode. A big thank you once again to Andrea Bombardi from RINA for shedding light on the evolving role of CCUS, its challenges, its opportunities, and its place in the future of the downstream sector and beyond. If you enjoyed this conversation, don't forget to subscribe for more insights into the technologies and strategies that are helping to shape the energy transition. Thanks for listening, and we'll see you again next time.
The Hydrocarbon Engineering Podcast is brought to you by Owens Corning Foam Glass Insulation. From managing vapor drive and mitigating corrosion risk, to maintaining thermal performance and supporting safety on the job site, the insulating system plays a critical role in high-performing hydrocarbon processing facilities. Learn more about how foam glass insulation contributes to the design of high-performing insulating systems at cryogenic facilities at www.owenscorning.com/foamglasslng study. That's www.owenscorning.com/FOAMGLASLNG study.